So guys, sorry for not posting anything on this channel for so long. I won't try to find excuses for that. Anyway, I will start over with a different project, and hopefully it's more interesting to you, because instead of just watching me code for hours, you get to see the end result, and I will point out the key aspects, the key things that you need to keep in mind to build something similar to what I'm doing. So the first project that we are going to attempt is this workout timer kind of application. And as you can see in the background, you can add multiple levels of groups of exercises, and you can define your workout however you want. This is just one example. So after you define your workout, we can obviously go open it. You see the current exercise, you see all this information, how long is left in the entire workout and how long is left for the current exercise. And at the very bottom, we have this start button. Let's see what happens.
Shoulder rolls.
So as you can hear, we have speech synthesis, or also known as text-to-speech, so that the web page itself will tell us what's the next exercise. And when we only have 3 seconds left, you will also hear 3 beeps that will prepare you for the fact that there is the next exercise.
Shoulder rolls reach knee.
So that was it. Very simple, right? It's just an application that has a list of workouts. You can add one, you can name it, you can save it, you can delete it. And that's pretty much it, and looks pretty simple. And then you have the workout runner here as well. But all this took me like 16 hours of recording, and because I don't think that you would like to sit for 16 hours and look at me coding this, I think it's a better approach to just show you guys what are the main parts of this. So let's go to the code. So as far as making the beeps and the text-to-speech thing, that's pretty easy. Before we have a look at that, let's though have a look at how the code is structured and how I organized it. And it's probably not the best solution, but it works really good for me. Okay, so first of all, we have this npm package, and obviously this is all stored in Git because you should really use a version control. We are not cavemen, so we don't share the code using pen drives anymore. And as you can see, this is a private one, but it doesn't really matter. The thing that is interesting here is that I use these workspaces thing that npm has, and that allows us to define folders with separate packages. So there is a package JSON here, and we have domain and React, and there is a package JSON here as well. And you can define the dependencies in this different package, but the interesting thing is that when you do npm install on this, it's going to install it in the main node modules where you define your workspaces. And that's also really cool, because then you can reference the code in your different projects and your different workspaces, essentially, just by using the package name when you import something. So I don't know, let's see if we have something here. So you can see that here I'm using this import from the domain folder using this notation here. And that's really cool, because then you can actually separate your code however you want, and you can use it together, and you can reference one project from another and those kind of things. The domain folder, we have everything that we need to everything that is business logic essentially. And then the React part is just a presentation layer on top of the domain. And it's also, the domain is also fully covered in tests. As you can see, we have 50 tests and we have code coverage. So if we add a file and we forget to add tests for it, we get annoyed by the code coverage not being 100%. Also, another thing to note is that if you have code coverage 100%, it doesn't mean that you have all the tests you want. It just means that among the tests that you already written, you're kind of executing all the lines of code in your files. But it doesn't mean that you cover a specific functionality that you want. You have to think about what you are actually testing and make sure that you cover everything and not just getting to 100% here. So I think I did a pretty good job, but maybe I missed something. You have to pay attention to these things. So in order to achieve this testability of the domain, you will see that some things that we want to test depend on things that when you run it in the browser, for example, storage in the browser is going to be in local storage. And of course, we will change that in the future and we'll probably use IndexedDB instead. But for now, things to keep in mind is that we abstracted away the things that we want an in-memory version of. For example, the storage. We have local storage in the browser, but when we run the tests, instead of using the local storage version, we use an in-memory version of the repository. And of course, it's a little bit annoying the fact that you're not executing exactly the same thing that you execute in the browser, but we are not trying to test if local storage works, right? Because that's not our responsibility. We are just trying to make sure that when we save a workout and we load it back, it kind of works, right? So that's what we are interested in. The exercise runner also uses an abstraction for the actions that happen during the exercise, like the beeps and the speech. So as you can see, this is just an interface, and then we have two implementations for this. One is a string array implementation, where the string array is a way to log that these actions happen, and we can access that in the tests. And of course, in the browser, we have the other implementation where we actually execute a beep. And for the text-to-speech, we do the text-to-speech thing, but we'll see that later. Okay, let's have a closer look at the domain layer. We have an exercise class, and this is essentially a node in a tree style. So we have the exercise class that has some properties like ID, name, second repeats, and then we have children to define if this exercise node has any children. And this is pretty much what you would see on the list on the edit page. So this is one exercise, and these are the children, and then children can have children of their own, etc. And of course, when we serialize this exercise, we need a version that is pure data, so we don't have any logic or anything like that. So we have this type just to define how that would look like. As you can see in the exercise itself, we have some logic like adding exercises, but we also have some read-only properties. One, to check if this particular node in the tree is a group or not. And of course, it depends if we have children or not. We have the total number of seconds, which counts the total number of seconds of all the children nodes and accounts for breaks and repeats and all that kind of stuff. And we also have other methods that we can use when we do editing or things like that. For example, we have the find method that you pass an ID and it will traverse the entire tree of exercises and will find the exercise that you are trying to find. And of course, this is used when you edit an exercise. You edit an exercise at the time, otherwise the UI gets too messy. And it's already messy as it is. We can improve it later, but for now this is good enough as a proof of concept. And we have a delete method that traverses the tree and deletes the specific a specific exercise by ID. And of course we have a serialized method and the parse method, so we can go from this exercise class that has business logic in it to a pure data version of the workout, so that we can use that when we store in the in local storage or wherever, or maybe we can send this to network in the future. So that's exercise. Next, we have the exercise runner. So the exercise runner is essentially what you see on the, I'm continuing to get the wrong one. So the exercise runner is essentially what you see when you try to run the exercise. So it's converting from the node tree list to a simple list of what's next. So this is just a queue essentially. And of course, for each repetition or breaks in between and things like that, we have that accounted for. So we actually repeat exercise when we have repeats and things like that. So that this is easier to run now because we just have a list instead of traversing the list. Instead of traversing the tree. We could have traversed the tree like straight away, but we would have to keep track of which repetition we are on so that we don't repeat too much and go back in the node and all that. But I think it just makes it easier to transform the tree version to just a list of things that needs to happen in order. And then it becomes quite easy to run this because you just go to the next exercise, and so on. Let's have a look at the code and see what we have here. So here, of course, we have the action that is abstracted away, and we have the workout, which is the tree. And from that, we kind of get the instances. We use this get instances method that will convert from an exercise to an exercise instance, which is pretty much the same but doesn't have any repeat or children or break, because when we generate a break, we essentially generate an exercise instance. So it's kind of simpler to work with. And we have this current repeat, which is an array that keeps track of, for each group, if we have a group with multiple sets or multiple repetitions inside another group with multiple repetitions, we can keep track of all of them at any level. But usually, yeah, it would be weird to have like a repetition inside of a block that also has a repetition, but it can happen. I don't know how complex your workouts will be. So here we also have, of course, the current second. So this is where the workout is at. And we have this method execute second that essentially executes whatever needs to happen for that particular seconds, and then bumps the current second to the next one. And this way, during the tests, we can execute seconds in a for loop and get straight to the result that we want, and maybe get to the end of the workout and test that things happened in the order that we expect. But of course, in the browser, this execute second will be run by maybe a set interval, so it will be called once a second. And of course, we have some helper methods like this is the second that I'm at, tell me what's the current exercise, and things like that. I won't go into the detail how these get instances work, but I think you guys got the idea that we are converting just from the tree view of the workout to just a list of what's next. And that's it. Okay, so now we have the exercise and we have the exercise runner, which are the classes that we use, one for the editing and one for the exercise runner. But before we go into the React bit, I want to show you how I organized the code for saving workouts and loading workouts. So I use the repository pattern to have like a generic repository that only has a few methods, right? And then we have an memory repo, and this is saving essentially just in an object, but we save it as string just so that we are sure that we are testing at least the serialization. So we can make sure that that works. Because if we serialize to string and we parse from string, then it doesn't matter if we serialize over the network or anything that you can think of, that should work, right? And then repository, instead of using the repositories straight in the browser, what we have services to execute any business logic. So the repository is just for accessing data. So that's the only thing that you need to do in the repositories. But maybe you have some more complex business logic in your applications, and you want to have like a service that executes maybe multiple repositories, saves in multiple places, does some logging or whatever your business logic should be. I don't know. In our case, the 4 methods that we have in the repositories, we kind of have those duplicated in the service. But as you can see in the service, we also have an additional method to create a workout, so that when we create a workout with the name, we just create it and we call this set to save it straight away. Okay, let's move to the React part and see how the presentation layer uses all this domain, which by the way, it's all tested. So we have tests for everything, and this is the coverage for it. So we have this React app. I used React, but of course, this could have been done in whatever framework we want, maybe Vue or Svelte or whatever you fancy, Preact, I don't know. It should all work in a similar way. We have some gotchas and some things that are specific to React, but using these domain objects in your own framework of choice should be very simple. So here we have 4 different routes, one for the home page, one for the edit, one for the delete where you confirm the deletion, and one for the run where you run the workout. And I prefer to have the pages in a different folder called pages instead of having, but these are not strictly different from any other component. It's just the fact that it's the entire page. Okay, so one thing to notice is that the way that I use services. So I have this create browser services, which essentially just creates this object with workout, and we create new workout, and then from there we create the local storage repo. Local storage repo is pretty straightforward. Essentially, we have a prefix for the workouts, and essentially we save each workout. Let me show you in the browser. We save each workout in a different key in local storage. So here we have this workout, but of course, if I go to the list and I will add a new one, you will see that we have another workout here. So now we have two workouts. And as I said before, this is already saved. We can edit it or we can delete it from the list. But as soon as you add workout, is created. So that's how local storage works. It's pretty straightforward. And yeah, when we get all the workouts, we essentially get all the keys from local storage, and if the key starts with the prefix, then it's a workout. Then if it's not, it means that we saved something else. The reason I've done it this way is just because when you get a single workout, I didn't want to deserialize the entire list. And also in the future we will change it anyway, so I think it's good enough. The reason I want to change it is because I think the local storage is quite limited in size, what you can store. I mean, we are only storing like a few workouts, so I don't expect you to have huge amount of data in there, but I think in the future we might want to save maybe the workout history so that every time you run it, you save the fact that you did that specific workout and things like that. And maybe we want to add the number of calorie burned, and maybe we can display graphs and all kind of stuff in the future. So make sure that you subscribe to see all those advancements in this project. I promise I won't abandon the channel anymore. I'm not sure how often I can make videos, so I'll try my best. So with this create services, what I'm doing in React, I create a context and essentially I save everything in the context. So this is the default value, but if we go to the app, we see that the current value uses essentially a memoized version of the services, so that not every time we change a state or something, we don't create the service again and again. It's just created once. And this way, when we need to use it, we essentially just need to get the services and use it. So for example, when we create a workout, we can import the context like that, and then use app services workout, get workouts, and that's a sync, and we save it. And yes, this is not handling errors and things like that. We will change it in the future. I just wanted to get this project done and get something to you guys. For styling, instead of using Bootstrap, I'm using TailwindCSS, and I kind of love it. So the way essentially Tailwind works is that you have these atomic classes that change one specific CSS style for your component, and essentially you can combine them, and you have also switches, like this is for disabled, but you can have switches for other things like dark and light and things like that. One thing though that I found hard at some point is what happens if you want to apply some styles only in specific cases during the execution of your application. So you can do that, but then when Tailwind tries to trim out the classes that you don't use, it's really hard for Tailwind to understand when you're using dynamic classes that you compose dynamically. The way I dealt with that in a couple of my projects, and this one as well, is by having these merge class names that essentially just concatenates two class names together with the space. And of course, if one of the two is null or undefined, it will just be empty string and trimmed out and all that. But if you define a local variable class name and you assign a literal string to it, Tailwind will understand that even if it's dynamic and even if it's inside of if statements. So you could have something like this: if something is true, then you can have class name and you add some additional classing things whatever you need for that specific case, and you can then combine all with the previous all and the new class name. And now that you have both these lines will be kept in the, so all the classes defined here is what I mean, and all the classes defined in here will be kept in the final CSS, so that you can be safe to use those classes. Another quick one is the fact that I'm passing the properties and I'm merging the class name here, right? But in order for the props of my button, which is just essentially just adding class names to buttons. So another trick that you can use in TypeScript is use this notation to get the properties of a specific element. So instead of having to type all this every time you want to use the same props that a specific element have, you can use this, which is a much shorter version to remember. Okay, let's have a look at how the beeps and the speech works in the browser. So for the beeps, I have this private method where we create an oscillator, and then we create a gain, which is essentially a way to amplify the signal. But the reason we need that is because we need to pass in where we want to play this sound, and in this case we say audio destination. We also connect the gain to the oscillator, and we specify the frequency, the type, and we also have a parameter for the number of milliseconds. And essentially we do start, and then with the timeout, then later we do a stop. And for the speech, we have this, we create this speech synthesis utterance. We give it a pitch rate. I just used one, it works fine. Maybe we can add a settings page later so that each user can change that. And we use the voice, we assign a voice to the utterance, and then we just call the speech, the speak method, and that does it. Okay, guys, so this is it for this episode. I hope you liked the project and the new format where I show you something that is actually working. We will add many features on top of this over time. We can think about a history page for the exercises that you've done, for the workouts you've done. We could transform this into a progressive web app, and with that we could make sure that our phone doesn't go to sleep while we are running the exercise. We could add WebRTC functionality to this so that you can share this workout with friends and family, and maybe you can do the workout at the same time. Really, the sky is the limit, and make sure you subscribe, you stay tuned, and if you have any ideas of what we can do and how we can improve this, let me know in the comments. Obviously, we will change the UI a bit. At the moment it's pretty basic. I mean, it's not super ugly, but it's not beautiful either. So definitely room for improvement there as well. So yeah, thank you for sticking with this so far, and see you in the next video. Bye.